Our next speaker is actually one of the founding members of the Electric Vehicle Association Scotland. That's just one of the many strings to his bow. Andrew Bissell is responsible for a company called Sunamp, and he will tell you more about that and some of the amazing services that they are able to offer to the world. And it's just astonishing right from now till forever. Thank you, Andrew.
Right, well, hopefully some of you are interested in things in energy storage beyond EVs. But I will just give a shout out to Evan Tuer and Adrian Loning, who were with me, the co-founders of EVA Scotland. Adrian was the first chair. He regrets, as does Evan, in fact, not being able to be here today. They've both been in touch with me about that. It's fair to say that we founded the association because we knew we needed a voice with government. It's great to hear that that's exactly what you're doing, the voice of the driver with government. And you know, that mission is really, really important. So, you know, keep pushing that. EV drivers can often be a little bit second or third or fourth or 10th in the list of priorities when it comes to thinking about EVs and the infrastructure around them. So, you know, keep banging the drum for what we need. Parking enforcement being a classic example. You know, that was brilliant from Neil to mention that. Right. So I'm going to talk about Sunamp. I'm going to talk about our world-leading thermal technologies. We have a vision, which is a world decarbonized by affordable renewable energy, sustained by compact thermal storage. Now that's obviously complementary to electrical storage, whether that's in vehicles or elsewhere. And our mission is to transform how we generate, store, and use heat so that we can make a significant global impact on tackling climate change and safeguard the planet, actually for ourselves as well as future generations. I mean, the impacts are now. If you don't mind, I'm just going to ask Neil to flick through a couple of slides, because I've been talking away, forgetting that I'm not in control of the slides. So this is the first one. Apologies for that. This is the mission slide next. Thank you. And I'm just going to run through. You're getting actually a sneak preview today of our new brand. You might have seen me come up with a mask on that had an old brand, which is going away as of the end of today, and our new brand is tomorrow. But we thought, what the heck, we'll launch it a day early here. So the next few slides just run through how we evolved the brand from thinking about actually the disk of the sun, which is the source of most of the energy, not all, obviously, but most of the energy that is renewable or low carbon. And just running through that, locking our name into the circle until eventually we arrive with our new logo. And we hope people will like it. If you go on to the next slide, I'm going to give you a little bit of personal history. For me, this journey starts in 2006, having sold a previous company, a medical imaging software company in Edinburgh, had a little bit of time to sit and think. Read a lot of popular science, a lot of New Scientist, for example, and started thinking a lot about climate change. And where I lived was along that row of houses there, on the Edinburgh seafront. And what I was thinking about was what sea level rise was going to do to my house. I mean, you know, very, very personal. Would it be in the living room by the end of the century seemed like a fairly sure bet. Would it be in the living room by, you know, mid-century? Seemed like a reasonable bet, actually. That's not good, you know. And then you think about the fact that there's hundreds of millions, possibly billions of people affected by that, just that on its own. So that became one of the drivers that led to Sunamp. Other ones were things like energy security. You know, back in the day, 2006, Putin was playing games with the gas supply through Ukraine to Western Europe. Well, that's the same today, actually. The same thing is happening today. Sorry to be political for a moment. So energy security was on the agenda. Fuel poverty is on the agenda today, was on the agenda then. Unfortunately, a lot of these things haven't been fixed yet. We're still a long way to go. Other trends, rise of megacities, decreasing space in people's homes. People are living in smaller and smaller properties. Rapid growth, though, in renewable electricity. That's a hopeful one. And that's actually gone faster than I was expecting. especially in Scotland, where we're basically delivering 2 times the amount of electricity we need, or something like that, every year. It's just not all at the right time, and that's of course where storage comes in. Pretty slow pace of change on renewable heat. I think it's still slow, but hopefully it will get faster now. Certainly in the UK, a lot of commitments, in Scotland, a lot of commitments towards doing heat pumps. And in the UK context, probably in a Dutch context, in a Korean context, incumbency of the combi boiler. That really handy appliance you can stick on the wall. It takes fossil gas, it's kind of storage, and turns it into heat and hot water instantaneously. Fabulous technology, terrible product in some ways, because it's pumping out CO2 constantly. So we adopted our own targets, if you like, inside Sunamp. Cut out the burn on demand of fossil fuel, link renewable electricity to heat, enable fully renewable heat, and make it fully affordable. And that's actually critical. And I'm not going to say we're 100% there yet, because we're not, but that's what we're working towards very hard. I'm just going to take a little side to EVs. In the same kind of time frame, I was really interested in getting an EV. I'd actually wanted one since I was a kid. They didn't exist then, really, but they'd existed previously. They didn't exist then. And plus, I'd been a child, so I couldn't drive one. And the choice is basically, sorry, next slide, please. The choice is, oh, sorry, I'm going to have to remember this next slide thing, Neil. I'm really sorry. So we'll do a little moment for catch-up. So the choices actually, when I started looking at EVs, were basically the G-Wiz, which is a quadricycle, or the Tesla Roadster. Now, I did try the G-Wiz. I actually also tried the Mitsubishi i, and I quite liked the i, but the iMiev, but it was a quite short-range vehicle, and I wanted to have a bit more range. I wanted to be able to drive all over the UK if I wanted to. So I ended up getting the Roadster because I'd sold a business, and luckily I could afford to do that. I've still got that car. I didn't bring it today because it's an older car now, and there's corrosion on the manifolds of the cooling system, ironically. But I'm going to get it fixed, and it'll be back on the road. If I go to the next slide, Neil, at the time where I jumped into EV, we were basically at that peak of 500 grams of CO2 per kilowatt hour. And it was a bit of a dicey question whether it was actually lower carbon to drive an EV than it was to drive a Prius. In fact, it was probably worse to drive an EV than it was a Prius, even if you took account of everything. But there was a chance that we would come down that slope, and in fact we did in the UK. In Scotland, much more so. I mean, if this was the Scottish graph, we'd be sort of sitting around, 30 grams maybe on average here today, and across the Scottish network. So that was actually, it turns out, a good choice, but you have to be kind of a little bit brave to make that choice, and I imagine most of you have been that brave, so thank you for doing that, and thanks everybody else who's jumped into the EV to do that. Another key thing, is to think about is, of course, the intermittency of renewable generation. It's often thrown against renewables, that they can't deal with base load, they can't do all of that. We think storage is the secret for that. Sorry, Neil, next slide. Thank you. And storage on the demand side, whether that's EVs, whether that's thermal storage, whether that's, hot water tanks, whether it's night storage heaters, whether it's electric batteries in people's homes, whether it's some part of industry, a tar store for doing the roads, which can be heated sometimes and not others. That's all important. It's all delivering a demand-side response to that intermittency on the supply side that comes with more and more renewables. And, Orkney, mentioned earlier, is leading the way in a lot of this stuff, as are many other places. If we go to the next slide, we also observed that when we looked into the statistics, and this is 2014 from the International Energy Agency, we tend to think about electricity as being the big thing to solve. Actually, it's not. Transport is much bigger than electricity in terms of final energy consumption, and heat is even bigger again. So we felt pretty good jumping into heat energy storage as our domain. And if we move on to the next slide, I'm going to tell you, again, brand launch, I'm going to tell you about our Plentigrade platform. So if we go to the next slide and play the video, effectively we start with the energy the type of energy storage that's in a hand warmer. Could you play the video, Neil? Thanks. So a hand warmer converting from liquid to solid warms up. You can throw it in a pan of boiling water later. You can recharge it. So that's essentially the inspiration that we took. We said, that's a reusable device. Unfortunately, if we go to the next slide, what you'll find is that although it's got 4 times, next slide please, 4 times the energy density, roughly, of hot water storage, so that's really good, it's actually quite unstable. The materials can be cycled 10 times, 20 times, or something like that, and then that hand warmer is going to stop cycling. And there's other problems with some phase change materials, flammability, toxicity, or they're made from palm oil, or various other things that we just thought were kind of wrong. Next, please. So we worked with the University of Edinburgh and tested ourselves at the Diamond Light Source, which is a large synchrotron facility in the UK. We were able to look right deep into the crystal structure of the materials, and we developed a new material that allowed us to have 40,000 plus cycles. So we've gone from 10 cycles, maybe 100 if we were really lucky, to 40,000. 40,000 is on 2 cycles a day, which is roughly what you need for hot water, is about 50 years, 55 years of use. So while I'm not saying that our heat batteries will automatically last 50 years in your house, the material will. And it may well be that products that we've installed in these last years will still be in use well past 2050. I very much hope so. And we could get all that reliable heat transfer, low-cost sustainable sourcing, non-flammable and non-toxic. So we've created this logo which sort of indicates a kind of almost infinite cycling because we think that's basically what we are delivering. If you go on to the next slide, and you'll just have to go through each stage of this, Neil, please. We actually started with some work done by Joseph Black back in the 1700s, a professor at the University of Edinburgh, also at the University of Glasgow at another point, and he did 2 things that are quite interesting. He discovered carbon dioxide, which kind of in a way sets the problem, and he also discovered latent heat. Latent heat is hidden heat. It's the heat which is there when you go from the solid to the liquid or the liquid to the gas. So when you go through that kind of phase transition, you are absorbing heat and yet the temperature doesn't rise. And he called that latent or hidden heat. And we use that principle. And we then build on the work of Maria Telkes, a fantastic Hungarian-American biophysicist who worked in the 1940s, 50s, and 60s in the US. She built the Dover Sun House, which was the first fully solar-heated house, we think, in the world, and it used phase change material, latent heat storage internally. That worked brilliantly for 2 years. Unfortunately, in the 3rd winter, the chemistry of the system crashed. And this tells us that we have to look really carefully at how the chemistry works in order to know that we have repeatability and cyclability of these systems. And I think that house carried on being solar heated with an annual change of the phase change material for about another decade. And eventually the people that owned it kind of gave up and said, yeah, come back to this later when you're ready. And then if we look at the most recent point, we've been working with the University of Edinburgh School of Chemistry, a fantastic and award-winning collaboration, and we've developed these new materials. And I think we've made the breakthrough that this sector, which is clearly quite old, has been waiting for. If we go on to the next slide, you'll see that, don't just take our word for it. We've worked with RAL PCM, which is a quality association, industry association in our sector, the phase change materials, to validate. Their cycle testing goes up to 10,000 cycles, not the 40,000 that we've done internally. So we get the top label, an A rating on their label. Can we go to the next one, please, Neil? And then we put that into a heat battery. And a heat battery essentially contains a high-powered heat exchanger. It contains vacuum insulation panel in the walls. And all of that is housed in an enclosure. It looks like a piece of white goods. It is a piece of white goods, effectively. It can go in your houseware a refrigerator or a dishwasher or a washing machine could go. And it has lots of nice things for the installer, easy access from different sides, but fundamentally, it's an appliance with a controller. Importantly as well, that vacuum insulation panel gives us extremely low heat loss. And that means that we're A+ rated on the ERP label. That ERP label is going through actually a cycle now of adjustment. And a lot of vendors of water tanks, which we compete with, have been pushing to lower the energy efficiency to get a top grade. We've been pushing the other way. We say the European Commission should be pushing to raise the standard so that everybody has to try harder. And if everybody has to try harder, we'll try harder and we'll get an A+ or an A on the new label. So what we end up with, if you go to the next slide, is a modular family of heat batteries ranging from about 14 kilowatt hours capacity down to about 3.5 kilowatt hours capacity. Comparable pricing to hot water cylinders that they displace, but in about a quarter of the size. And I'll show you that as we go on. If we go to the next slide, I think we'll just briefly dwell here. They can be heated internally from an electric heating element. So in some ways, they are directly compatible with demand-side response, with off-peak tariffs. In fact, in my house, they are charged at the same time as the electric vehicles, of course. But they also have this high-power heat exchanger, so they can get really high output performance. And again, a little bit of a sneak of the brand launch tomorrow. We're calling this Thermino going forwards. Up till now, people have known it by another name. If we go on to the next slide, you'll see what the impact of that high efficiency is. We can save about 1 megawatt hour of electrical input a year compared with heating up an electrically heated hot water tank that's already in somebody's house maybe for the last 10 or 20 years, has relatively low grade of insulation around it. So while we wouldn't encourage people to throw things out that are perfectly good and serviceable, when people come to the replacement point, they should definitely be thinking about something that saves 1 megawatt hour per year of electrical input. Next, please. And this is what we mean by compact. So over here on the, just make sure I'm your way around, on the left, is what we compete with. It's a really great hot water cylinder. That's a Heat Ray Sadium Megaflow, top brand, no problems with that. We produce the thing that's on the right, does exactly the same amount of hot water, does it with an A+ rating. The Megaflow is a B-rated cylinder, and there's a lot less pipe work to fit with ours because we aren't actually a pressurized water cylinder. We're actually a thermal store. Next, please. And I want to show what that boils down to in real life and why it makes a difference to decarbonisation. So here we have in Sunderland, a little bit south of here, sorry if it's going too long, I'll speed up, seven tower blocks with 364 apartments in them, very small cupboards, closets in order to put some equipment, and need to get rid of the combi boilers that are up on the top left, and we replaced them with, if you go on the next slide, where would you put that tank? Nowhere. It couldn't go in that property, but instead we're able to put the heat batteries in the closets and combine them with the very compact shoebox heat pumps from partners Kenza. And that works together with a ground loop that's shared across the building. That solution is now deployed in about 1,000 properties so far. And tower blocks are a really, really difficult to decarbonize location, and we're working very hard to get as many of them decarbonized as quickly as possible. Next, please. And we can do the same for air source heat pumps as well. So let's keep moving on and through the next one, please. Just a very quick shout out, if you can go on the next one, Neil, to our partners. We work with all of these heat pumps. So if you've got a heat pump need and you want thermal storage with it, choose any of these, it'll be good. Next. We offer a lot of flexibility for system designers. And here I'd like to turn back to vehicles for a moment, if we can go on the next slide. Gary, are you here? You said you might be. Yay, excellent. Good. So could I introduce Gary Hayes? Gary, maybe stand up for a second so people know who you are. Perfect. So Camper Van Co. is a partner of ours, and they're developing a zero emissions recreational vehicle. Zero RV. I'm not sure quite how to say it, but I'm sure you'll tell me in a minute. And it uses, it can be a plug-in hybrid, it can be a full electric. I believe the plug-in hybrid is the current generation. There'll be a full electric beyond that. Is that correct, Gary? So if you go on the next slide, when it's plug-in hybrid, well, there's an engine there. Okay, and lots of people look at ways of reusing the waste heat from engines. They talk about doing organic Rankine cycles. They talk about doing thermoelectric generation to electricity. Actually, in our view, the best thing to do is to save the heat into a heat battery. And if you go to the next slide, you'll see what Gary then does with it. He turns it into the supply of heat and hot water in the RV. Makes a lot of sense. And in future, of course, that's going to be fuel flexible, so it will be able to charge presumably from the grid. When you're plugged in at a campsite or an electric vehicle charger, it'll be able to charge from PV, and it will be able to charge from engines where fitted. So, we're really proud that we're not just for the built environment, but we're also for EVs. Next. And we're also doing big things. So coming middle of next year, you'll be able to buy a megawatt hour plus scale containerized heat battery. And that will be available in multiple temperature grades, ranging from -30 Celsius for refrigeration and cold storage, all the way up to about 120 Celsius for low grade steam production and high temperature hot water production, and all the temperatures in between. And over time, we'll extend that range. And that's going to go into things like district heating. It's going to go into wind, power to heat, essentially wind to heat propositions. It's going to go into industry, and it's going to be, we think, pretty important. I was also asked, if you go to the next slide, to talk for a minute about COVID vaccine distribution. That might seem like a pretty strange pivot, but give me a minute on this. This came out yesterday, I think. It was Gordon Brown and a number of other global leaders pitching to the G20, ahead of COP26, around the fact that actually we're being too slow doing the vaccine rollout into the developing world. The wealthy countries, probably most people in this room, maybe everybody, has had 2 vaccine doses. Some of you might have had 3. Lots of people in the developing world, most of the people in the developing world have had 0. A couple of % or something like that, full vaccination. It's too slow and too little. And if you go on the next slide, you'll see that about a year ago, we were absolutely on this agenda, and we said, let's take what we do in the heat battery, not all of it, but let's take the insulated shell, and let's make something that can store vaccines at -70 to -80 for 24 days. We chose 24 days because at the time there was a lot of talk about 3 weeks between doses, and we were thinking about, taking something to a remote island, taking all the doses, delivering it, and keeping the vaccine safe at -70 for the full period between dose 1 and dose 2. Subsequently, we've worked with partners Eco Mirage in the UK, and they're turning it into something that's much more kind of robust, much more oriented towards, for example, rapid response military deployment, rapid response civilian deployment. They're working with the International Red Cross and so on. So, we are working hard still on this agenda. And actually, we're very keen to make sure this technology gets out there to support what is still a very live agenda, the need to get the vaccine out to a global population, not just the population of our wealthy countries. Next, please. So we're all about accelerating global impact. We're working today across the world. We've developed a second factory in Korea. We're working on large projects in China. We're working on global vaccine rollout. We're working on UK projects. We've just kicked off a project with NYSERDA, the New York State Energy Research and Development Authority, across in New York State to do 8 commercial demonstrators there, which will be the beginning of our entree to the US market. We've sold 15,000 heat batteries to date, And actually the pace of that is accelerating rapidly. And we've signed up key OEMs and international distributors. And on the last page, you'll see that, for us, this is still about realizing a vision. It's not just about making lots of money, because if it was, I'd have gone and retired by now. We seriously think the world needs a massive amount of thermal storage. It's going to have to be compact because people are living in compact places, and equipment rooms in industry are compact and so on. We've seen a huge impact, bizarrely for us, from the pandemic. Our order book grew 500 times during the pandemic to £100 million from 200,000 before the pandemic. I think a lot of people focused in the early days of the pandemic, thought really hard about what was important, and maybe made choices they weren't previously making, which has been good. We're targeting to get to 1 million products a year by 2027. That's about 2% of what we really need to be doing to make the impact. So if we can accelerate that more, we will. We've raised some money. We're delighted that Scottish National Investment Bank supported us with £6 million a few months ago, and we'll be raising our Series B into the beginning of next year. But ultimately, the money is to make the vision happen. So if you go on the last slide, we're on a mission to enable renewable heat with compact thermal storage. Thank you very much.
Thank you very much, Andrew. Right, so I'm just happy to open the floor to any questions.
Hi, I'm Nate from Slovenia. I have a question. Hi. Do these products require any kind of maintenance, like for the vacuum that's inside or something like that?
Actually, one of the great things about them is there is absolutely zero routine maintenance attached to them. I would expect that, most of the products that go in will never see a day's maintenance ever. And, maybe a few percent will end up needing some attention because something fails, like the electric heating element or so on. We give a 10-year warranty on the heating element along with everything else, which is unusually long, because it sits in a very reliable place inside a phase change material that we know very well. So no maintenance. Thanks, good question.
Okay, any other questions? Well, I can, you.
Thank you. Hi, is there a limit to the amount of heat that you can input into this system at any one time? So you were saying about the inbuilt heating element, for example. If you were to combine that with a high temperature, high power heat pump on a sunny day when you've got like an agile octopus price plunge or something like that, so you've got super cheap electricity, is there such a thing as a limit to the amount of heat and power that you can put into it at once?
Somewhere around about 30 to 100 kilowatts is probably the real limit of charging. So you could probably charge a device in, the biggest device that we offer residentially, you could probably charge it in 20 minutes if you had all the right equipment to go with it.
I'm going to need a bigger power supply.
You need a bigger power supply, exactly. Yeah.
Okay, and we have
there's
one more down at the front.
Thanks.
Here. 2 seconds.
Hi. Can your batteries be a solution for seasonal heat worries, like heating in winter and having excessive heat in summer?
So that is such a great question, which I'd love to have a positive answer to today. It was definitely an objective when I started. I looked at that house I was living in and said, 100 square meter house, if I could capture on the roof all the energy that falls in the summer, with standard efficiency, PV and solar thermal, and store it, I could power my winter heat requirements. We're still a way away from that. I would say the problem with interseasonal storage, we can do it technically, but the problem with interseasonal storage is it gets, I think stats say about 1.4 cycles per year on average. So there's some intra-seasonal use. And so the problem, it becomes an economic one. How do you make that work? compared with, say, taking real-time electricity off the grid when it's available, and maybe going down to a one-week store. A one-week store feels like, 1 week, 10-day store might be a happy medium in between interseasonal and where we are today. Where we are today is kind of 1 to 2 days, but I think we'll get towards where you want to go. Whether we can do it economically ever with any technology, apart from really big water stores in Denmark, for example, work well, and they are used. So it's possible, but probably not with our technology to arrive exactly where you'd like to be. A little box in your house, and it stores it interseasonally.
It may have to be a big box, and I know about the initiatives with water.
Yeah, it might have to be a big box, but with a big box, yeah, we could do it. And if you're into that and you want to talk more detail, absolutely happy to do it. Thanks.
Right.
Great. Okay, shall I step off?
Thank you very
Thanks a
much,
lot,
Andrew.
everyone.
That's been really informative.